Now, this example, let me bring that example here. We have a weight hanging by cables. Two cables there, and then all of those two cables, cable AB and cable AC, connected to the ring B, and ring B is on this other side connected to another cable that is holding the weight at D. It's in a static equilibrium. Because of that weight, the cable is connecting the ring B to weight D is under stretch. Those cables AB and CB are also under stretch. Right? Everything is, the weight is pulling down everything, so they're under stretch, which every cable should be. If it's not under stretch, the cable doesn't even exist. So the problem is telling us to determine. Let me read it from. Determine the tension in cables AB and BC necessary or so required to support the 60 kilogram cylinder. So what I need to know is that I want to find the force in these cables, cable AB and cable BC. Now we know it's in a static equilibrium. Which part do you suggest I draw the free body diagram for? Which part of this system? Right? So I want to find out what is the value, the force in this cable, which we can think about as TBC, and the force in this cable, we can think about it as TAB. I want to know what these two forces are. That's what I'm asked for, tension in these cables. So rule of thumb, to find out which part you have to isolate to draw the free body diagram for, typically we start from where we have the most information. Look which part of the problem, which part of the situation that you're in, you're given the information for. What is the information I'm given in this case? The problem statement. There's only one piece of information there. Right? If you look at the problem statement, I'm told that the cylinder is 60 kilograms. That's what I'm told. So I'm going to start from there. Again, rule of thumb, you start from where you are given the most information. If I am given the information about the cylinder, I'm going to isolate that cylinder and draw the free body diagram for that. In this case, let's draw the free body diagram here for this cylinder. This is just the cylinder. Forces applied to it. What are forces applied to this cylinder? If I isolate that, what forces I have to put on this isolated part out of those four forces?
Weight in the cable force.
Weight and cable force. Exactly, Diego. Thank you. So weight, downward, cable force, upward. I'll call this W, and I'm given 60 kilograms, so 60 times 9.81. Cable force, I don't know, TBD. So far, we've done this before. Now, what we do is that we use the equilibrium. Summation of forces, vectors, are equal to 0. Now, what are the vectors Look at this, just forget about the physics of the problem, Newton's law. Look at this, two vectors. We have W downward, TBD upward. So the only thing we have is summation of forces in y direction. If you take this direction as x and take this direction as y, it's optional. You can just do x and y in the other way. They should be 0, meaning that I have TBD minus 60 times 9.81 is equal to 0. Right? I applied the equation of equilibrium to my free body diagram with all the available forces. Remember, this is a key statement. When a system is in static equilibrium, take a note of this somewhere. Remember that. When a system is in a static equilibrium, every part of the system is in a static equilibrium. So when I tell you this whole system is a static equilibrium, any part you take, you isolate, draw the free body diagram for, should be in a static equilibrium, meaning that vector sum of all the forces should be 0. Following that, the system is in equilibrium, static equilibrium. I started from where I'm given the most information about, which is 60 kilogram weight, mass. So calculate the weight, look at this isolated like part, free body diagram for that. I get two vectors, one upward, one downward. I assume that this is y direction, and I take TBD upward as positive, W downward as negative. Summation of them should be 0. From there, we can find TBD. If you do the calculation, do this multiplication, you will get 588.6 newtons. All right, keep that there. Now I know the tension in this cable. I can go back, or I can go one step further. Now, remember what I want. I want the tension. So start from where you're given the most information, work your way towards what you are asked to find. You want to find the tension in AB and tension in BC. So the next step, I'm going to isolate this part, ring B. See what happens there. So this is for cylinder, for ring B. Here is the ring B. Similar to what I did for the knot here, right? Knot C. I'll just apply all the forces if I isolate this part. So there's one cable downward, one cable in this direction, one cable in this direction. Naming, we can go with T, so tension and cable TBC, TAB, and the tension downward, that is TBD. Angles, there you go. What are the angles? So that one I'm given directly. This is 45 degrees. What is this angle? Can someone tell me? Let's go with alpha. What is that angle?
45.
Well, 45 is the other one, right? But in order to find that angle, you have to take a look at this triangle here that you are given. 3, 4, 5, triangle there, this triangle there. What does this is trying to tell you? It's trying to tell you that if this is 3 and this is 4, this is 5. So that angle alpha is the same as this angle. So the information about the angle is given to you in the form of a right triangle. This is 3, 4, 5. Find the angle. Now, you say, well, if this is a right triangle, alpha is tan inverse what is in the opposite over what is adjacent. 4. Or you could just say alpha is sine inverse what is in the opposite over hypotenuse. Or you could say alpha is equal to cosine inverse what is adjacent over hypotenuse. All these give you the same value. If you do the calculation, you'll get 36.87 degrees. So I knew 45 degrees that were given on the right side, the angle TBC creates with the x-axis, x that I assume. But I wasn't given the angle that TAB creates with the horizon, x-axis. I had to find it now. I used a piece of information from the problem statement, right here. 3, 4, 5. So right triangle, the ratio between those sides are given. That's how the information for that angle is given to me. All I need to do is that I have to find the angle based on those dimensions. Now I can find the right triangle, alpha is tan inverse, opposite over adjacent, sine inverse opposite over hypotenuse, cosine inverse adjacent over hypotenuse. Either of them works. I usually go with tan inverse, opposite over adjacent. So this angle becomes 36.87 degrees. Once you have that angle, then the rest is dealing with vectors again. Remember, a vector, now you have summation of forces is equal to 0. You have summation of forces in x direction is equal to 0. Summation of forces in y direction is equal to 0. Once the system is in equilibrium, static equilibrium, every part of it is in static equilibrium. So if I follow that, summation of force in x direction will give you TBC. That's why we practice vectors. TBC cosine 45 degrees minus TAB cosine 36.87 degrees is equal to 0. I take this direction as positive and I take upward as positive. It's optional, up to you. I usually take x and y and then take x as positive in the right direction and y positive in y direction, in upward. If you do the other way around, you still get the same result. For y direction, you will get t minus TBD. Look at the composition of vectors. TBD is downward and is negative. So downward is negative because I took upward as positive. Plus TBC sine 45 degrees plus TAB sine 36.87 degrees. This is equal to 0. Now you know TBD, right? I'm almost done. Sorry, I know that we passed the time. Give me another minute. We know TBD. TBD is 588.6. 588.6. So we're going to end up having two equations, two unknowns. If you replace these values, you're going to get square root of 2 over 2 TBC, right, cosine 45, minus sine 36.87 is 0.8, TAB is equal to 0. Square root of 2 over 2 sine 45, so it's TBC, plus 0.6 TBA, or AB right there. And I'll take TBD to the other side because that's on that's the known value. Sorry, this TBC we don't know. I shouldn't have put it here. Only we know TBD. This becomes TBD goes to the other side, becomes 588.6. So two equations, two unknowns, we can solve this. Right? Whatever method you know, eliminate one, multiply one by negative, and eliminate. You can multiply the top one by negative. Right there, multiply this by negative, becomes positive, and sum them up, you get TAB, and then once you know TAB, we can find TBC. BC. If you do that, you'll get TAB and TBC. TAB would becomes 42.43 newtons. TBC becomes 475.66 newtons. And this is what you were asked to find.